at points, it's just because I'm looking outside of the window instead of talking to you people. But yeah, this view makes up for the 37-hour trip that I had to take to come here. I have a bunch of cat stickers, so if you would like a cat sticker, who does not, tweet me a picture of your cat, your dog, your grizzly bear, your Canadian goose, whatever you want, and I'll give you some stickers after this talk. But that's about it for my introduction. Let's see what we're going to be talking about today. A little bit of history on passwords, some kind of the different types of passwords that are commonly used these days. Passwordless authentication, and in the end, I'm going to be talking about the future, which is the Web Authentication API. Anybody ever heard or used the Web Authentication API? Nobody. Perfect. So, a bit of history on passwords. Somewhere before Christ, passwords date back to the Romans. There's been some written accounts or whatever. Some clever people figured out that Romans used to use passwords. Like if you would be a group of Romans, and you passed another group of people, you would say, "What's the password?" If you did not know the password, you would probably get into a fight. If you knew the password, you would probably go for some beer. So the Romans used passwords to distinguish friends and foes. So it's a very old technique. Somewhere in the 10th century, you have this story of 1001 Nights. Who's ever heard of the story of 1001 Nights? You all know Ali Baba, his famous cave with the 40 thieves full of gold. To open that cave, you had to say, "Open Sesame." So open sesame, it's a password. So all along in history, we've seen passwords, Romans, stories. There's so many different examples of passwords. So they've been in use for a very long time. Now, if you skip forward a bit to 1961, there's this very smart guy named Fernando Corbato, which worked at MIT. And they invented a time-sharing system. Basically, in the 60s, not everybody had a computer with its own CPU and hard drive. They kind of had one computer for the whole department with one hard drive, but they wanted as many people to be able to use this computer. So they figured out a system to do some time sharing on that system, and they allocated a bit of disk space to everybody, and they could just open that disk space with a password. So the first use of a password with computer science has been used since the 60s. Then in the 70s, another genius, Robert Morris Sr., invented hashing, which means that the first 9 years of computer science passwords, they were not encrypted, which is not good. I hope you all know that you have to encrypt, hash, salt, whatever you want, passwords if you want to store them safely. But the first 9 years, this did not happen. Of course, it was less of a concern back then than it is right now with the internet. So from the 90s onwards until now, hacking becomes more of an issue. We try to keep our passwords secure, but we don't always succeed in this. So that's a bit of history on passwords. So some types of passwords. The first thing I want to go through is, what is a password? My definition is anything that's a shared secret is a password. If it's a sentence, it's a password. If it's a PIN code, it's a password. As long as it's a shared secret between me and the client, person, party that needs to verify this password, it's a password. And then, of course, the most common one is a string. Don't use this as a password. I hope you all know this. This used to be my first password when I was very young and opened my first Hotmail account. I don't use this anymore, so don't try it on whatever accounts I might be using. But it's a string. Nowadays, we try to make them a bit more random, a bit more harder to guess. So if you would be using a password, it might look something like this. But they can be very hard to remember because I don't know what this means. This doesn't mean anything. It's just random characters. So if I have to type this over and over and over again, I will not be able to remember these. So a password manager can help. I usually ask this, but who uses a password manager? Most of you. If you don't, try it out. I cannot say this enough, and I'll probably say this at least 10 times in this talk. Use a password manager, just because it makes managing passwords so easy, and you can make your passwords a bit more difficult and random and more difficult to guess. But if they're that random, they can also be hard to guess by others, which means they're a bit more secure than cold or password 123. So a random-looking password can be quite difficult to guess by others, can be quite hard to hack. Another form of a password is a PIN code. We all use this with our credit cards, with our phones. Sometimes if you want to enter a building, you also have to type in a credit card. Or I've seen a lot of cars here in Canada which also have some numbers on their doors. Never seen that before, but apparently that's a thing. And the downside to these PIN codes is they're not so hard to guess because they're usually 4 or 5 or 6 digits. And there's just this amount of combinations you can make with these digits. But they're often combined with something physical, with your phone, with your credit card, with your car, with your door in your building. So unless you have access to that physical thing, guessing that password would be useless. So combining it with a physical thing makes it a bit more secure anyway. The good thing is they're fairly easy to remember. We can all remember 4 digits, 5 digits. If not, I'm sorry for you. And they're usually used with access to a physical thing, like I said before, your card or your phone or whatever. A next form of a password is a pattern. If you use an Android phone, you might have seen this or might use this. Who uses this on an Android phone? A few people. And what this is basically just a pattern that creates a password, a string, a PIN code. Don't know what the underlying logic is, can be anything, but just this pattern converts to a certain combination, a password. And one of the downsides of this is that touchscreens can often reveal the pattern because who cleans their screen every day or every hour? I don't think nobody does that. And people often use their initial letter or their lucky number as a pattern, so they might be easy to guess. But again, they're very easy to remember. So what's the problem with passwords? Because all of these passwords we've seen do have some upsides. They're easy to remember, they're hard to guess by others, so there must be some downsides with passwords. Imagine this, you have this login form, username, password, and you log in. Where is my mouse? Okay, so first time, it's not correct. So you retype your password, try again. Not correct because it's hard to type a password. Type again, 3rd time's the charm, not correct. What do? You reset your password. So you reset your password, type a password, reset it, and then it was supposed to show a very funny message, but it did not do this. This. Who's come across this in their life? I have, because I always think I know my password, and it usually do, but when I have to type it, I get a bit nervous, and I type a mistake, and I type a mistake again and again and again, so I reset it. Turns out I knew my password all along. So passwords can be very, very user unfriendly because you have to remember them, you have to type them correctly. Can be annoying. So use a password manager to help you remember. That's the 2nd time I said this. More to come. The downside with passwords is also that user data can get stolen. If you look at last year, Google Plus lost a bunch of records. They didn't lose passwords. They lost just private data. Facebook with Cambridge Analytica lost a lot of private data, no passwords. Quora, 100 million. I think you can see the trend in numbers, they're going up. MyFitnessPal, 150 million. Encrypted passwords, luckily, no unencrypted, but some services still store passwords unencrypted, like Google recently had to admit that they stored a bunch of passwords for certain accounts as plain text. So it's not only small companies, it's also big companies who do this. Marriott, last year, or 2 years ago maybe by now, 500 million user records got stolen, or they got hacked. Which means that if they store their passwords wrongly, unencrypted, they can also get stolen, and once somebody knows your password, that's not good. We have a certain feature in our product which helps you detect breached passwords. So if you would log in with our service, it would tell you like, hey, your password has been breached. You might want to change your password. Google as well has a plugin for Chrome, which also does the same. If you try to log in on a service with a password or a username that has been breached, it will tell you to change your password because they're not safe anymore. So some tips for a good password: use a complex password. Don't use personal data, so don't use your date of birth or the name of your kid or dog. Don't reuse passwords, so use a different password for every service, every website, every app that you use. That's annoying. Again, password managers can help you with that. And change them frequently. Who changes their passwords on a frequent basis? Nobody does. I don't do that either. But to be secure, to be more safe, it's better if you change your password every half a year, every year. Some companies enforce this as a policy that you have to change your laptop or your email password every year, just out of security. If it gets leaked, it's only valid for a certain amount of time. So if you want to create a good password, these are some tips. But again, passwords are annoying, hard to remember, and I don't like them. So if you skip forward, passwordless, in the form of a one-time password. Who's ever used a one-time password before? I see some hands. I think many of you have used it without even maybe realizing it. But what a one-time password is, it's valid for one-time use, like it says, one-time password. It often expires after a certain time, so they're only valid for 30 seconds, a minute, so they're only valid for a certain amount of time. And they're sent directly to the user through certain methods, which we'll see now. The first one is when you get an SMS with a one-time password. And the good thing is, iOS and Android let you fill in the one-time password with the press of a button. Like if I would log in on GitHub on my phone, I have two-factor authentication enabled. My second factor is a one-time password. I get a message on top with the one-time password, and my keyboard would just say, do you want to fill in this password from your messages? Android has the same function. So that's very convenient. Just one tap of the button, you can fill in this one-time password because they're sent directly to your phone. Not all telecom operators take security seriously, so SMSs can be intercepted. That's just a fact. Nothing we can do about it unless you are a telecom operator or work for one. And you need your cell phone on hand. Sometimes you're in a different room. Sometimes you forgot your phone at home maybe because it was very early in the morning and you didn't have your coffee. So if you want to use a one-time password sent to you through an SMS, you do need your phone on hand, which can be a bit annoying. The second way is send in an email. If you use Slack, you might have seen this email me a link before. Has everybody ever used this magic link of Slack before? A few people are nodding. Perfect. What this does is basically it's going to generate a link with a one-time password. You click on it, and this password is going to be used for one time. It's only be valid for one time. So you don't have to enter your username and password. You just click on the link instead. The good thing about this email, getting it in email, is that you don't need a second device because usually you have your email set up on the same device that you're using at the moment that you request your one-time password through an email. Again, emails can be intercepted. Nothing we can do about it, and there's always too many clever people trying to abuse every system that's out there. But it's a good way, a convenient way to get rid of passwords and just use this one-time password. The next one is an authenticator app. Something like Google Authenticator. Anybody uses this? Yeah. Perfect. We also have one, it's called Guardian, does more or less the same thing. And there's a bunch of others, Duo, LastPass, Authy, even Microsoft has one, so even if they take it seriously. Must be something. And there's a few other out there, but what they do is they generate one-time passwords for you. And they're often time-based. Like in the Google Authenticator app, you have this little pie chart, and your your one-time password becomes red when the time runs out, and it's going to generate a new password every 30 seconds. They can also be push-based. So instead of you copying that code, filling it in on a website, you could get a push message which you just click on or tap on, and it would take you to the website, fill in that one-time password for you. But they rely on a shared secret between you and your service and the one-time password generating service of that Authenticator app. So if that secret gets leaked, anybody can generate one-time passwords. That's not the best. But we kind of just rely on these services and hope they are secure because that's what they do. But you never know. Social. Who uses login with Gmail or Facebook once in a while? Why do you use it? Convenience. That's a perfect answer because that's also my answer. We use it because it's convenient. You're often just logged in already on Gmail or Google or on Facebook. So you just have to click on it. It does all the magic for you. You don't have to you have to register and type all your credentials, your username, password, and whatever. It just works very easily. And it's one less password to remember because you only have to remember the one of your Gmail account or your Facebook account. Only have to remember that one. And it gives you only give your password to a service you trust. If you choose to log in with Gmail over and over again, it kind of means that you trust Google with your password. Even though I just mentioned they lost a bunch and they do not always encrypt them, you kind of still trust Google to handle your passwords in a secure way if you log in with Gmail all the time or with Google. But you rely on another service for authentication, which means that if they do something bad, if they go down, you cannot log into all the other services because you rely on that service to log you in. So that's a downside. There's some other services like It's Me, which does some voice recognition and face recognition. Yodi does some very advanced face recognition. VoiceIt, the same. Oh, It's Me, it's something Belgian. I was wrong. VoiceIt does a voice recognition and face recognition. So they all use different ways to generate one-time passwords or generate a way to log in without an actual password, being it your face, your voice, some other biometric thingy. And they're often used as a second factor, and that's important because most of you who have used a one-time password before, SMS, email, authenticator app, that's just for your second factor when you have two-factor authentication enabled, right? I think so. And that's good, but we want to get rid of passwords, so we want to get these one-time passwords as the first factor. So maybe we can do something else instead of one-time passwords which are generated and sent to us directly. Maybe we can use the Web Authentication API. It's often referred to as WebAuthn, so if you want to Google more about the Web Authentication API, you can just Google WebAuthn and you get more results. It's just like this. And what it is, it's a key-based authentication mechanism. It uses public keys and private keys to authenticate, which means that it's inherently a bit more secure because of the public key and private key and how they work. They use hardware authenticators, something like this. It looks like a USB drive. I have one here on my keychain. It's very small, so I doubt you can see it in the back, but it just looks like this. This is a USB-C one. I have a bunch of different ones here as well. You have the Google Titan key, which is kind of big, but it works. They also have a Bluetooth one if you have an Android phone. Open source ones exist, and then you have YubiKeys as well. And this is just a keychain in form of a beer bottle. Also important. So they're hardware, which means that it's a different piece of hardware that's going to take care of generating things for you, public keys, private keys. It's not your device itself most of the time. They can work through USB, Bluetooth low energy, NFC, because not every phone you can just put a USB-A, whatever, stick in it, so you can connect them with Bluetooth low energy or NFC. YubiKey is also, I think you can pre-order them now, one for Lightning, for iPhones and iPads. So most devices are starting to have some way of using a hardware authenticator with them, even if it's through USB, Lightning, Bluetooth, or whatever. So who has one of these devices? Few people, very cool. Not that many, but I think 4 or 5. And what I do basically is, if I would connect one of these to my laptop, in theory I would be able to authenticate with this device because it has a private key, it can generate public keys, it can do all of that, and I can just exchange those public keys and do some things with it. So if I click on this button, my browser is going to do a request to this authenticated device. I have to touch it because that's a security thingy. And because I'm on localhost, I have to allow it. Usually you only do this the first time. On localhost, it keeps on asking you this. And what I just did is I sent a challenge to this. I'll explain a bit more how it works in detail later. We signed the challenge and we got a raw ID back. So by just touching this key, I got a raw ID back, which I can use in the future to authenticate. Okay. But I just asked who has one of these devices, and I saw 4 or 5 hands. Well, I'm pretty sure that most of you, if not all, have a laptop or a phone which is younger than, let's say, 10 years. Who does not? I think we all have a very modern device, right? And all of these modern devices, iPhones have an A2 or whatever, A12 chip, forgot the number. Intel chipsets have their own chip which does the same thing. Most modern chipsets, most modern devices have a certain dedicated chip which does nothing but generating keys and managing them for you. So they do basically what this USB sticks drives do in your device built in. So in theory, all of you have an authenticator device in front of you, in your pockets, in your backpack, wherever you want to store them. So if we take the previous example again, instead of me touching my USB drive, which I attached to my computer, I click the login button again, and then it opened a prompt, and it asks me to touch my Touch ID because my laptop has Touch ID built in. I say allow again, and again, we don't get anything back, but we should get back a raw ID, which means that I can use my built-in Touch ID of my laptop the same way I can use these USB attachment devices, which is convenient because they are built into your device. You cannot forget them on your nightstand, on your keychain in your car, or whatever. They're built into your device, which is, oh, there you go. Which is nice. So how does this work? The first thing, it kind of works in 2 steps. The first step is you need to create new credentials, create new key pairs, private key, public key. So what you're going to do is you're going to to your website, it's going to ask you, can you fill in your username? You're going to fill in your username. It's going to you're going to send this to a certain authentication service or whatever. It's going to send back a challenge. A challenge is basically just a random buffer, a random string, something random or seemingly random. And you're going to pass this challenge through the browser to that authenticator device. That authenticator device just created new keys. Is going to use that private key to sign that challenge with some user interaction. So you have to touch your authenticator device, you have to touch your Touch ID, you have to, if you're using Windows Hello, you have to do some facial recognition. So you have some kind of user interaction. And then you're going to send this signed challenge together with your public key to your authentication service and store them there for the future. So what we've just done now is, based on our username, created a key pair, private key, public key, and signed a challenge with those keys. Once registered, you can use these keys saved to authenticate. So the next time your user is visiting your website, it's going to enter its username again, just so we know who we're dealing with. So in my case, it would be Sam. And we're going to look up in our authentication service, in our database, do we have some keys saved for this username? If so, we're going to send the raw ID of that key together with a new challenge to the authenticator device. The authenticator device is going to check, do I have a private key stored with that raw ID? If so, I'm going to use that private key again to sign this challenge and then relay them back again to your authentication service. So based on this saved public key or raw ID, you can look up the private key on your device and use the same one to sign your challenge again to confirm that it's the same user that's trying to authenticate. So to recap that, register a challenge, sign a challenge, send back that signed challenge, raw ID, and public key, and save the data together with the username. That's when you register. And when you authenticate, you kind of do the same. You request a challenge. You request the raw ID of the user that's just typed in his username. You sign that challenge with the private key that corresponds to that raw ID. And if they match, the user can authenticate. So let's look at some code, because it's still a technical conference and I didn't show you any code yet. I'm not going to show much code, and it's JavaScript. Some people here might be like, ooh. But the Web Authentication API is a browser API, so it works with JavaScript. And it's fairly straightforward. You have 2 methods. The first one is navigator.credentials.create, which you use to create new credentials, to register new credentials for a user. And it accepts a config object, which has a bunch of things. The first thing is a challenge. This is this randomly generated buffer, at least 16 bytes long. It's just something that we're going to sign on the authenticator device. The second part is some information about the relaying party, your authentication service, your website that is going to be using this. So in my case, my website, sambigo.tech, the name of that one is Sambigo. So it's some information about the relaying party. Second, some information about the user. You assign it a user ID, again, a buffer with some bytes in it, a name and a display name. It's important to know that this user ID cannot contain anything that can be linked to a user. It should be anonymous. So don't include your name or email or username inside that buffer. It's always random or seemingly random bytes inside of it. So that's the next part. Then we have some information about which public and private keys we're going to accept. So in this case, we're going to accept public keys with the algorithm -7. You might say, I've never heard of the algorithm -7. Me neither, but there is this list here, which has a bunch of algorithms listed, again with their value. And if we would look up -7, you would get to ES256, and you might have heard of that algorithm. So it's just a short way of writing algorithms than just writing them fully. And this is an array, so you can accept multiple different algorithms, multiple different kind of credentials, or just one, whatever you choose. The next one, a timeout, which means how much time does the user have to complete the whole registration process, going from touching your key to sending back the signed credentials and raw ID. It's in milliseconds, so this would be 15 seconds. And then if you want to exclude some certain credentials, for example, if you want your user to only register one credential per service, you can check in your database if you already have some registered credentials and put them in here so the user cannot register a new kind of credential. So these will be excluded. And the next part, maybe the most important part, is some information about the authenticator device. Because I've showed you a bunch of different ones and they all behave a bit differently. Touch ID verifies the user based on biometrics. My USB drive does not. So you can kind of select which ones you want to accept. The first one, authenticator attachment, platform or cross-platform, which means the platform are the ones built into your device. Touch ID, Windows Hello, Face ID, should Apple one day decide to support this standard, which they do not yet. So they're the ones which are built in. If you put this to cross-platform, they're the ones that are not built in, like the USB devices. User verification. Does the user have to verify that it's him or her that's doing this request? With Touch ID, you can verify a user based on a fingerprint. By just touching your USB drive, you're verifying that somebody is doing something, but not really who's doing something. So if you want to be a bit more secure, you can just only allow the ones that verify the user identity. And then requires resident key. We're going to see a bit more about this later. And then if all goes well, in the end, you get back an attestation object, and you can set if you want to have this attestation object directly as generated by your authenticator device, which means it might contain some identity information about the person doing this operation. You can also choose to anonymize it. You can use the attestation object for this. So basically, it's just one method which accepts a whole bunch of config, which you can use to fine-tune how you would like to implement this in your website. But this one method will generate a new credential for the user. So once you've used these credentials, you can use navigator.credentials.create. That should be get. I made a typo. So you have create to create credentials and get to use previously created credentials. Again, it accepts a config challenge. We've seen what it is. Then the allowed credentials. So we're going to look up, do we already have some credentials saved for this user? If so, we're going to pass them along in this array. So for this user, we already had a credential saved with the ID 1, 2, 3, 4, and some stuff in the middle. This means that we're going to look for these credentials on our authenticator device to sign the challenge if they're available. And then again, you can choose to set user verification to preferred if you want to. So it's a bit shorter than the create object, the create config object. The most important part is that you can choose which credentials you will allow the user to authenticate with, to log in with. So resident credentials. It was the other option in your authenticator selection thingy. Up until now, the user has had to type in their username, which we would then use to look up in their database, do we have some stored credentials, which is still annoying because typing username can still be some work, like 1 second. But it's still a step we could try to avoid, or we want to avoid, just for being a bit more user-friendly. And resident credentials can help with this. So we set them to true in the authenticator selection. And what this does basically is going to save your user credentials on your authenticator device. So your username, user ID, a special kind of key for that on your user device. So the next time the user wants to log into your website, we're not going to ask it the user to type in the username, look up all these saved credentials. We're just going to check if there are some saved credentials for a user on our authenticator device, and if so, use those. An example of this is if I use a different one. Let's see. We have this website, which is a bunch of information about WebAuthn. I'll tell you a bit more about it. But one thing it has a debugger, which basically has the whole configuration I just talked about. And you can just change them and see what it does on the fly. So if we would use a name voxed and a username voxed user, whatever, and we would set the authenticator selection requires resident key to true. We're now going to require a resident key, which means we're going to register a credential on our authenticator device for the user voxed. And do that. It's going to ask me which one to use because I have both Touch ID and my USB one. I have to touch it. This one requires a PIN code. I type that one, have to touch it again. So it's a few steps, touch it twice, enter a PIN code, but it did create a resident key on my authenticator device. Your attestation object looks a bit like this. There's a bunch of information in it. The most important part is the raw ID. This is what you usually save in your database, which you're going to use to look up your keys on the authenticator device. But in this instance, we don't need it because we saved them on the authenticator device. So if you would now authenticate and don't pass any allowed credentials, I have to touch it. Again, and we would see all the saved credentials on my authenticator device, one of which I should put the timeout a bit longer. So let's try again. Authenticate, no allowed credentials, and 50 seconds. Touch it, PIN code, touch it again. And these are the credentials I saved on my authenticator device. And as you can see, voxed user is the first one, which is the one we just created just before this. So this eliminates the need for having to type in a username at all. You just plug in your authenticator device and just say, I want to register or I want to authenticate on this website. The website is going to check, or the browser is going to check, do I have any credentials saved for this website? So it's based on the relaying party ID, so on your URL most of the time. If so, it's going to show you a list of them, and you can choose whichever you want. So if I choose voxed user and authenticate, I have to touch it again. Do that again. So there's a lot of touching and typing involved. That's because it's kind of new in Chrome, and they haven't really figured out how to do it perfectly.
So is the PIN code related to the
cancel.
device, or is it?
Oh, I just forgot that I already did. Yeah, so the PIN code, you can or cannot. You can choose if you want to set up a PIN code on most of these authenticator devices. But if you want to register a resident credential, you have to set up a PIN code. So what you do is, most of these devices have some kind of configurator thingy software you can install, like YubiKey. YubiKey has a little app you can install, and you can just configure a PIN code. If you don't do this, and let's try that as well. So I plug in another one which does not have a PIN code does not have a PIN code configured. Let's refresh just to make sure. And then do this. Require resident key, and we're going to try to register some credentials with a key that does not have a PIN code configured. We'll use that one. Touch it. This one is a bit more difficult to touch. Live demos. Anyway, this should now ask me to set a PIN code. Let's see. Close. I wrote a blog post about this some time ago, and I have a screenshot in here. So it would show you this screen where you can enter a PIN code and set it on your device. You have to do it twice, like most of the times. So if you would use a device which does not have a PIN code set, but is able to, the browser would already ask you, do you want to send a PIN code? Otherwise, you cannot save resident credentials on your key. So it looks a bit like this. Well, if you enter it, it's just one. So there's still some issues to be solved, like you have to touch your key twice, which is annoying because we try to use this to have a better user experience, but if you have to touch it twice, still enter a PIN code. It's not the best. The other thing is user credential management. You can erase all of the user credentials saved on your authenticator device, but you cannot edit a certain credential or delete a certain credential. That's still not possible. So it's either all or nothing. And most of these USB sticks, these authenticated devices have a certain limit of user credentials you can save. And I think it's a very low number, I think 6 for YubiKeys. So it's still new. How to manage these credentials is still something that is not really implemented in any browser. But they're thinking about that. Also cross-device credentials. If I would use my Touch ID built into my MacBook to register, to authenticate for a service, but I also want to authenticate on my phone, I cannot use these credentials which are stored on my MacBook on my phone. So how to share credentials across devices? It's still something that needs to be figured out. Usually you will create a new set of credentials on your phone as well, and they're both stored for your user account. So you can create as much credentials on as much devices as you want, save them in the database linked to your user ID or username or whatever, but you cannot share them across devices yet, because the thing about these authenticated devices is they're safe, you cannot access them, so you cannot copy credentials from them to another service. At least that's the idea. So if you lose your authenticated device, your USB drives, or your phone breaks, or your laptop breaks, you might be locked out of your account, so you always need to have a backup, like some security codes, or maybe a password as a backup as well. So you need some way to recover your account if your authenticated device gets stolen, broken, lost, whatever. So WebAuthn might replace passwords. I think it does, because in the end, if you can just click on your username, type a PIN code just for some security, if it would work with Touch ID or Face ID, you would not have to type your PIN code because you have another way of confirming something. It's a bit easier than typing a username and password over and over and over again, even though password managers make it a bit easier. It's still a better solution. But WebAuthn does not replace token-based authentication, authorization, OAuth, OIDC, identity providers like Auth0 or competitors. I get this question a lot. Are you afraid of this new technology? Is it going to hurt your product? No, it does not, because you're always logging in with a password at the moment. If we can just replace that with a key-based approach, it does not do anything to the real authentication and authorization services you use for your apps. And it's a W3C recommendation, so it's an official spec, the official standard. It's been implemented in Chrome, Firefox, Edge, and Safari Tech Preview behind the flag on Mac OS, not on iOS. So you can use this also on Chrome on Android, but if you want to use it on an iOS device, you'll have to install Brave, which is the browser by, I forgot who. Anyway, it's an open source browser which does support it, but then you need one of those YubiKeys which have a Lightning connector, and I'm not sure if they're already available or still for pre-order. But it's coming to iOS in the Brave browser, and maybe one day when Safari or Apple decides to take it out of Tech Preview and well, behind the flag, it might also be available in Safari. If you want to do the Touch ID, that only works in Chrome on macOS or on Chrome on Android phones. So native Chrome on iOS still is not a native Chrome, it's just a web view wrapped in a little app. So it does not support that. So where can I use this? If you want to log in with Google, you can already do it with this. If you want to log into GitHub, you can already use one of these authenticator devices. Often there's still an option as a second factor, just because there's still some few things that needs to be figured out. But you can already use it today on a lot of bigger services, bigger websites. They have some blog posts about this GitHub just announced it in August the 21st, so that's about a month ago, that they fully support the web authentication standard. I showed you this before, and I will show it to you again. If you're interested in this, we created this website, WebAuthn.me, which basically has the debugger, which lets you play around with all the config variables and see what happens. You can see the output of it. It has some information, and it also has this interactive tutorial, which kind of lets you see the whole flow of what's happening with a standard request. So if I would type in a username, we don't save any of this, so you can type in whatever you want. You can see that it's going to ask for a challenge to the relying party, take that challenge, send it to the authenticator device. Then you have to use it, touch it. Something went wrong because I have this one authenticator device. It's plugged in, which doesn't work. It's an open source one, it has some issues. But it basically shows you the whole process of what's going on, the back and forth between your browser, relying party, browser, authenticator device. So if you're interested in learning a bit more about this, WebAuthn.me. So let's summarize. Boo passwords. I don't like them. I think we can do without them. I hope we can do without them. Well, one-time passwords are cool. They're convenient, often used as a second factor, not as a first factor. It's already a step in the right direction, but WebAuthn is even cooler because it's a native, built into browsers, W3C-backed official standard. The spec is finalized, so it's not a draft anymore. It's just finalized spec. And it can eliminate passwords and even the need for entering username all the time. WebAuthn.me, the spec, you can find it as well. If you want to learn more about it, so if you want to know what all the config variables do, I wrote a blog post about it, which you can find on our blog. And also, if you want to know more about resident credentials, saving these credentials on your authenticated devices, another blog post about these. There's a few other ones on our blog. So if you're interested in it, have a look. If you want to see the slides again, 1990.somemega.tech. They will be here. They might evolve over time because these slides evolve over time, but the general content will always be in here. Thank you very much. Are there some questions? Yes.
So for a long time, passwords have been an extremely easy attack vector. As we start to move to passwordless, I'm assuming attackers are going to either go against the key exchange protocols or against like stealing session tokens, right? Are you seeing any of those attacks in the wild? And what what is Auth0 doing, or what would you recommend as best practices for securing those other avenues? Depends on which kind of app you're building. So every kind of app has its own considerations, especially if you want to prevent the stealing of tokens. If this is a single-page application or a native mobile one or a desktop app or a server-generated web app, it all depends on the kind of app. So yeah, a lot of people are trying to steal tokens. That's why, for example, you should never store them in local storage when you're building a single-page application. Because if you would Google how to do authentication with single-page applications, 99% of all blog posts or tutorials would tell you, just store them in local storage and that's fine. But it's kind of easy to steal anything from local storage, so don't do that. I can talk to you a few hours if you want about all the considerations. So yeah, stealing tokens is something that's happening a lot, or people are trying. Stealing of these credentials is a bit harder because the private keys stay on these authenticated devices. You cannot access them. I cannot see these private keys. If it's not like a regular USB drive that you just go to your Finder or your Windows, Explorer or whatever, go into and see, oh, there's a file with public key written on it. I'm going to steal this and I have your public key. It's not like this. It's made to be as secure as possible. Of course, it's hardware. People are always trying to hack that as well. But you still need access to the physical device. So it's a lot harder than just trying to steal passwords. But no doubt that people will try to hack this as well. Are you seeing any attacks against the registration? Because like there is a registration event. The thing is, what you send from the authenticated device through the browser to your relying party, your authentication service, whatever, is all public data. So it's a public key and a raw ID of a private key. So the raw ID is just an identifier of a private key. It does not have any of the actual private key in it. So should you steal, which is perfectly possible because it just goes through some JavaScript, everything you steal is still public data, public key, signed challenge, and an ID. So you're not really going to be able to use that in a certain way. Does that? Yep. Yeah, that's good. Okay. Any other questions?